Hey everybody, this is Larry. This is me doing week 4 of the Leetcode bi-weekly premium challenge. What am I talking about? But this problem. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this problem. 1660, correct the binary tree. A problem that I have not done before, so I'm excited to kind of give it a spin. I'm still in Hong Kong right now, just living life, I suppose. Yeah, follow me on IG, though maybe not today, maybe tomorrow. You have a binary tree with a small defect. There is exactly one invalid node where its right child incorrectly points in an okay. So there's one node that is wrong. Is it a binary search tree or just regular binary tree? Remove this invalid node and every node below it. How do we know? Oh, how do we not? I mean, oh, the same depth. Okay. I was gonna say like why like what would be the rule for not using the one instead, or like in this case also the one I suppose. Um. Okay. Hmm. This is a medium problem, though I struggled a lot with the last medium on the contest. So I mean it's not so bad. I think it's just. Mm, I mean, it's gonna be breadth first search. I mean, I was thinking about using some depth first search thing, but breadth first search makes the most sense because breadth first search then, because they're on the same depth, and this is very specific for this problem. If they're on the same depth, then you visit all the nodes on the same, or not you visit, but you put it on a queue to be visited at the same time, right? So yeah, okay, yeah, I mean, I think that should be good. So let's get started. Just attack. Do they have unique whatever? The values are unique, so we could hash on the values. We can also hash on the node itself directly, but it really doesn't matter, I suppose. So yeah, so scene is equal to a set, right? Uh, and then we can maybe just do scene dot add a root. Right? One label q is greater than 0. Node is equal to q dot pop left. Right, and then basically just q dot okay, for next node in node dot left, node dot right, right. If next node is not none, then yeah, q dot append. This isn't quite right yet. Hang on, I know. I'm just typing out the what you may say a template code. But yeah, and okay, yeah. If this is not node, then if that node is in scene, then that means that this is the bad node, right? That node is the bad node because and it is pointing at something that we've already put it into the queue. So yeah. So that means that no, I mean, I think this is fine. Is equal to none. No dot right is equal to none. I think that's it, right? And then we can return. Otherwise, do we do anything? Do we have to? Oh, I guess we have to return. But, and I guess we return the root, right? Like, what is from node and to node? Oh, no, that's just indicating the bad nodes, I guess. How does the pointer stuff work? Maybe I'm misunderstanding. Not quite sure. Let's just do at least a print statement, right? Node dot value, bad node, right? Something like that. Too lazy to format it. Okay, so it does know that the 2 is a bad node. So I have to remove this node and every node a node. So not just every node below that. Okay. I mean, there are a couple ways you can do it. You can just look up the parent, which is kind of annoying to set up, but not impossible, right? So yeah. So here, I guess it cannot be root because there's no other node on the same level. So then now with node parent, right? Then now here parent dot left. Oops. And then here we want to and that should be good. I mean, now that we actually read the prompt correctly. I've been trying to go too fast lately, but yeah. Okay. Oh, okay. Yeah, that's true. I was trying to remove every child of the parents. I got a little bit lazy, so I'm wrong about that one. But so yeah, if parent dot left equals to node, and okay, now it should be good. I said that like 4 times, so I inspire no confidence, but still the idea is right. I mean, I think that's one takeaway as well. Is that if you structure your code and your ideas in a good general direction, the modifications are kind of easy, which is why maybe I don't pay attention that much. But sometimes it bites me in the butt, so I don't know what to tell you about that particular part. But for this particular problem, yeah, I think BFS is the way to go for the reason that we mentioned. Is just that because the thing about pointing at a node at the same depth is the big one. Yeah. Um, that's all I have for this one. I don't really have much to say. Um, much more to say. Uh, this is depth first. Oh, sorry, breadth first search. So this is going to be O of n, or n being the number of nodes. Also O of n v plus d, you could say per se, but the number of edges is always going to be 2 times the number of nodes at most. For left and right, but this is a tree, so actually there's only n nodes, right? N minus one, or sorry, n minus one edges, but there's an extra edge, so there's n edges. So this, in either cases, it's going to be O of n, or linear time and linear space for the queue and the scene, I suppose. So yeah, and in case you're wondering, the scene it hashes based on the. You could say it's a reference pointer, but technically in Python it's like an ID thing, but as long as you're giving the same reference, it'll give you the same hash. So yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.